Hello there, Skeptic Squids. If you haven't watched Dr. John Baumgardner get a Geophysical Part 1, you should go check out that first by either clicking the card thing up there or checking down below. If you've done with that, join me in watching Dr. John Baumgardner fail at geophysics.
So let me at this point give just a quick tutorial on the large-scale structure of the Earth.
And I'll follow along making corrections and giving more info.
With this same map I've shown before, let me focus on a number of features. One, that the continents represent a layer of buoyant granitic crust with a density of about 15% less than the rock beneath it, and also the rock that makes up the ocean floor, about 20 miles in thickness of this lighter rock.
This is not 100% accurate. The thickness and composition of the continental crust varies wildly. It ranges all the way from 20 kilometers all the way up to 90 kilometers, averaging about 35 kilometers. The composition in general is granodiorite. The oceanic crust, on the other hand, has a relatively straightforward stratigraphy. It averages about 10 kilometers deep and is basaltic in composition.
These mid-ocean ridges, it was quickly realized, represent where two plates are pulling apart and new ocean floor is being formed.
He actually uses the correct term here. The plates are really being pulled apart, not being pushed apart by the mid-ocean ridge.
As hot material rises to fill the gap. And then what are known as deep ocean trenches, for example, that exist, for example, off the coast of South America and Central America, is where ocean plates are plunging into the earth, back into the earth.
It's actually missing a couple of other crustal boundaries, such as oceanic continental transform boundaries, where the two plates are simply sliding past each other, and continental-continental convergent boundaries, such as the collision between India and Asia, causing large-scale orogenesis.
This is a close-up depiction of what it looks like at an ocean trench, where this cold layer of ocean plate is plunging back into the earth, carrying down a little bit of sediment. Most of the sediment is scraped off at the top, but a little bit of sediment is left on the plate along with some water. That water causes the material to have a lower melting point, so when it gets down to sufficient depth, there's a great deal of melting.
This is not exactly true. Any water contained in the pore spaces of the sediment and in the cracks of the rocks are cooked out very early in the subducting process.
And we get volcanoes, typically, commonly. So the ring of fire around the Pacific corresponds to where you see the melting occurring here. Now that's today's world.
That explanation is very lackluster. It makes it easier for him to inject his nonsense into the model, but obviously it does not reflect real life. The Wilson cycle is a model explaining the opening and closing of ocean basins. When dealing with oceanic and continental convergent boundaries, we'll be focusing on stage G of the Wilson cycle. Our story starts the moment when oceanic crust decouples from the continental crust and descends into the mantle. This is called the subduction zone, and eventually it will lead to Caldera orogenesis, a fancy word for volcanic arc mountain building. There are a few interesting features about a subduction zone which I'd like to point out. The first would be that as soon as this plate starts subducting, it pulls down a large part of this crust here down with it, which causes a lowering of the seafloor about 2 kilometers and which could lower further. A good indication would be the Mariana Trench, which is about 11 kilometers deep. Another thing is that sediment accumulated on this plate would also be scraped off by the continental plate, or the overriding plate, forming a accretionary prism, also known as a melange deposit. Eventually, however, the water contained in the capillaries would be cooked out. It gets quite hot as this plate is subducting. Now, At one point, there is something known as a flux heating, where the water contained in minerals get cooked out and then cause the surrounding mantle to melt. This should not be confused by pure water in liquid form from the crust level. That water is already lost through the initial phase of the subduction. Oceanic continental crustal convergent boundaries are probably one of the most complex topics in geology. Here's a little diagram just to explain sort of kind of what is going on, why this plate is actually subducting in the first place. It's important to note that when the plate is formed at the mid-ocean ridge, it's still quite warm, so it's more buoyant than the older part as it cools down. It works like convection. As the plate's cooling down, eventually it loses its buoyancy. So the crustal or the continental crustal plate would be more buoyant than the oceanic crust. This means the oceanic crust can then buckle, subduct underneath the continental crust and then descend into the mantle. Once this starts happening, the subduction process speeds up because you have a bigger part that's subducting in the mantle and has greater potential energy because of gravity. Now, a few other things happen simultaneously. Number one is the sediment is being scraped off by the leading edge of the continent, causing an accretionary prism. Water is being cooked out, and eventually it reaches a point about 150 kilometers down where the water from within amphiboles gets cooked out. When this water reacts with the mantle material, then it acts like a flux, causing a melt. Now, the mantle material is not completely homogeneous. It wouldn't just melt at one point. Something called fractional melting takes place. It follows the thing called a Bowen's reaction series. I have a picture up there. So when it starts crystallizing out, it works from the bottom up. A melting process works from the top down. So you'll find that as a melt starts here, a basaltic lava would turn into a rhyolitic lava. So you'll have more felsic material in this melt here. This will move up, working its through the granitoid rock, causing more fractional melting, eventually leaving you with a very sticky melt called, well, I can't remember what it's called. Leaving you with a very sticky melt called a siliciclastic melt, which would form a stratovolcano, which would explode violently. Pretty interesting, right? Now there's a couple of things that would change this process. Number one is time. Relating to time would be the velocity of whatever is going on here. So a plate that's subducting quicker will have this melting happen a bit later. A plate that is not subducting at such a great angle would cause this part here to be squeezed out. So the temperature would not be as high, which could also mean that maybe no volcanism forms, or the volcanism forms very far inland. When there's more material here, sometimes phlogophyte is incorporated into the basaltic crust, or oceanic crust, which would cause a secondary volcanic chain. If this subducting plate subducts at a more steeper angle, it could pick up speed and cause the volcanism to happen a bit closer to the forearc. Another thing that might happen is when this thing picks up speed and bends down, it could actually force this entire top part here to move backwards, causing this entire section to move forwards as well. These things all depend on time. Millions of years worth of time, not simply days, as we'll explain in just a bit.
And what I want to look at as a mechanism I believe is responsible for the flood is can be described by the term catastrophic plate tectonics. And in this case, these ocean plates sink very quickly, actually run away as a result of an instability that can occur inside the deeper earth known as the mantle.
The idea of runaway plate tectonics is just absurd. The only instability in the mantle would cause such a thing to happen would be a literal cavity. The forces acting on the subducting plate is immense. About 60 million years ago was the fastest plate moving ever, and this was when the Indian plate was moving to the Eurasian plate. It was moving at about 170 millimeters a year. The main problem is the amount of force acting on the subducting plate. When it's moving through the mantle is not just liquid lava, it's extremely dense, albeit viscous. Another thing is the plate is actually three-dimensional. There's other parts of the plate that's preventing it from subducting, not just this little part here. Also, the abducting plate is acting like the huge brake pad, slowing this plate from subducting in the first place. And it's not just this little contact zone there. It's three-dimensional. The entire plate has forces working onto it. That's why there's like a speed limit, a universal speed limit, if you will, acting on these plates. They can't just accelerate into infinity, that's for sure.
And when this runaway takes place, the surface is pulled down dramatically by kilometers. So this region where the plate is bending is pulled down by many kilometers, and this process, and as well as the continent, adjacent continent, is also pulled down and flooded.
Yes, a trench does form, only about a few kilometers deep, and as in your case as well, the crust, the continental crust in this case, would also bend down slightly. You don't explain even like how far the bending is in your case. You don't give any detail.
So we have some, when this happens a million times faster or more than it is today.
What? A million times faster than today? That would mean let's for instance take the fastest the continent's ever moved, which is 170 millimeters a year. Times that by a million, which would give us about 170 kilometers per year, or about 0.47 kilometers per day. From answers in Genesis, the water rose to its highest level at around 150 days since the beginning of the flood. This means that the continents could only have moved about 70.5 kilometers, so it would have left the Earth looking like, well, this. Now the distance of the opening of the Atlantic Ocean is roughly 2,594 kilometers. So that would be 2,594 divided by 150 would give us 17.29 kilometers per day, or about 6,310.85 kilometers a year, or about 37 million times faster than in real life. So that's again, you say a million, using a bit of math, it gives us 37 million times. That's quite fucking fast, to be honest.
So catastrophic plate tectonics basically relies on the fact that ocean plates can sink because they are cooler and therefore denser than the mantle rock below. This 2,000 thick layer of rock below the plates is known as the mantle. It's almost everywhere solid, not liquid like a lot of people have been led to think. It's solid rock.
So you admit that it's solid rock, yet you claim the oceanic crust is moving through this solid rock at 17.29 kilometers per day. Also, why do you say the mantle is weak under stress? If this was the case, why isn't it still happening today? Why isn't this runaway plate tectonics still occurring to this day? Why?
And below that is the core, which is molten for the most part, a small solid inner core we know from seismology. So you can basically divide the Earth into two main parts, a rocky upper part, about 2,000 miles thick, and then a mostly iron, mostly liquid core. Anyway, the picture is that for this catastrophe, that the ocean plates sink rapidly on the order of meters per second into the mantle.
Moving at meters per second. But 17.29 kilometers a day is about 0.2 meters a second. You should really be checking your math. Let's say, for instance, the plates are moving at 1 meter per second. It would then move at about 86.4 kilometers a day, and a total of about 12 1,960 kilometers during the flood, or about 185 million times faster than the fastest plate movement ever. That's not a million. Now we're already at 185 million times faster. When is this going to stop? Where is the consistency? There's no consistency. You see, if your argument and the mantle had the consistency of about the same, then yeah, runaway plate tectonics would be a thing. But the mantle's consistency is pretty damn tough. That's why I don't have runaway plate tectonics. That and the fact that it doesn't make any fucking sense whatsoever.
So, before I go into some numerical modeling of this process...
Wait, what? You did numerical modeling? You can't even do basic maths. Look, you can make computer simulations. You can run computer simulations until you turn blue. Garbage in, garbage out. Bullshit in, bullshit out. This is how it works. Your numerical models mean absolutely fucking nothing. They're useless. They're bullshit. And if you really want to see numerical modeling, just go onto the sites I listed below. The mind boggles at the complexity of these forces. But, a little model there we go. Obviously it's true because you did computer modeling.
So we have molten magma rising to fill the gaps where the ocean floor is pulling apart and is sliding like giant conveyor belts into the Earth's interior. Steam generated from the hot rock at these ridges erupts as violent supersonic jets. Jets like this, where we have water circulating down through the hot rock, becoming supercritical. There's a supersonic shock, supersonic velocities in these jets. Some of that high velocity steam entrains liquid water as it rapidly penetrates the layer of ocean water, and that water comes down as heavy rain.
I really have no idea why you think it would turn into a supersonic shock. The water would just spill onto the magmatic material, turn into steam, boil. It'll boil all the water on the face of the Earth, all of it, and it wouldn't explode. It would just boil. There's a video by the Hydraulic Press channel, their little extra channel, link down below, where they put like a solid piece of metal, super fucking hot, into the water. Just boils. It doesn't explode.
And this solves a major problem for creationists in the past of how we could condense so much rain. Here, there's no need to condense the water. It just falls down it never goes to a vapor phase. It falls to the earth as liquid water. Of
course, it makes sense to you. Well, it really doesn't, but it promotes the Bible, so yeah, there we go. It's all of the convincing he needs.
As these ocean plates plunge into the earth at the continent margins, sediment from the pre-flood ocean bottom is scraped away and accumulates at the continent edges, provides a major source of sediment. As the hot rock from the base of the mantle rises and spreads rapidly beneath the ocean plates, the volume of the ocean basins is greatly diminished and the global sea level rises dramatically, as I've already indicated. Intense water currents in the form of giant eddies and driven by the Earth's rotation arise over the flooded continental areas as the global sea level rises.
No, you just said that the water turns into steam. Let me just repeat what you just said.
Steam generated from the hot rock at these ridges erupts as violent supersonic jets.
See? Turned into steam. So, no water for you. None of it. None of the water. Not even one amount of water. Like 0 amount of water, okay?
I reported this at the 1994 International Conference on Creationism.
Of course you did. That's the only ones who believe in your nonsense. Also, your entire theory doesn't sit well with Walt Brown's hydroplate theory. Chick Takada did a video on that as well. Seriously, these two theories just don't mix well together, like water and oil. Water and they don't mix, okay?
A chance discovery I made that these high velocity currents arise spontaneously.
Put garbage in a simulation, get garbage out of the simulation. That's it.
So thick sediment sequences are spread out in blanket-like manner over the emerged regions of continent to produce this layer cake pattern of sediments over the continents.
Yeah, you passed that little thing very quickly, John. Is it because it has an actual deposition system with faulting and folding, and the fact that it's completely incompatible with your model? Just saying.
And of course, most living organisms perish in such a catastrophe.
No, John. Your model will kill everything very quickly, almost instantaneously, and the runoff will literally deposit everything along runoff systems and deposit the majority of the material, including fossilized, or I should rather say organic material, because at that point it hasn't fossilized yet, at the continental shelves. Because of the mass amounts of runoff, it would be one layer. Like one, not many, one. That's it.
The flow of rock in the mantle, driven by the sinking seafloor slabs, moves the continents apart by thousands of miles and opens the Atlantic and Indian Oceans. So we have, for the most part, North and South America moving westward relative to Europe and Asia and opening the Atlantic Ocean and forming this mid-ocean ridge where the seafloor is spreading apart.
Disregarding the other side of the Earth entirely.
Now, all of this is driven by the gravitational potential energy of these heavy seafloor slabs that have this natural tendency to sink. However, when they reach the bottom of the mantle, and when the hot rock at the bottom of the mantle reaches the top, this potential energy is mostly exhausted. And when this happens, the runaway episode ends, the velocities and stresses diminish, extreme surface deformations relax, and the global sea level begins to fall.
This is utter nonsense. There's so much wrong with your model. I can't believe you have a PhD and just don't understand what's going on in geology. Let's take this model. Let's assume the first tiny part did happen. There was some cataclysmic event going on in the mantle and rapid plate tectonics started. Let's assume that just happened. And let's see what's wrong with that. So, initial phase, we have a rapid movement. We have the oceanic crust subducting underneath the continental crust. And that's it. This is what happens. This part here is what actually happened in this model and what we'll assume is true. This entire subduction process, worth of hundreds and hundreds of kilometers, happened in a question of, let's say, 3 days. This happened. So, obviously, there's a few things wrong with this. Number one is, what about the rest of the oceanic crust? What about that? The crust is not strong enough to be pulled at that speed. We know this from when we look at continental arcs. We have something called trench rollback, where the oceanic crust pulls back and pulls a part of the crustal or the continental crust with it. We have faulting there and thinning of the crust, because this happens relatively quick. In reference to the continental crust movement. So we know it will just rip apart, and we have mid-ocean ridge systems popping up all over the place. It'll sort of be like, well, honestly, it'll be like stretch marks. That's pretty much what will happen, and you have volcanic material moving up. Secondly, there's no folding going on here, because the crust is too stiff for that. It's too strong. It hasn't heated up enough yet to be able to fold. So once it hits more harder material, it would simply shatter and buckle in. Well, it wouldn't buckle, it would just shatter like glass almost, because it's not hot enough to bend like taffy. This part here at subducting is very much cooler than the surrounding mantle. Eventually it would heat up, but that would take hundreds of years to heat up to the same temperature. Oh, well, it actually could take millions of years to heat up and duck in the fall. So, on the continental crust, we have a massive melange deposit. This entire part here exists solely because of all the sediment that's been scraped up. And the sort of metamorphism you'll see here would be more akin to continental collision. Yeah, that's correct. I did say continental collision. It's two continents crashing together. That's a sort of metamorphism you'll see here. High strain, high temperature metamorphism. You'll find all along this zone. Usually you'll find eclogite, that zone there. But you might find something completely different with a different texture because of the high temperature. You'll also probably have a part of the continent here breaking off and fracturing down with the rest of the oceanic crust. Also notice there's no volcano there, because the volcano wouldn't form in days, because this material here has to melt first. If it goes slowly, it has time to melt around 150 kilometers deep, when the amphibolite or the phlogophyte gets, or the water inside those minerals get cooked out. It wouldn't happen here, it would take too long. Eventually, it would happen at a much lower depth. We'll have the material being cooked out, causing flux heat, or flux melting of the mantle, which would eventually cause massive volcanism here. Eventually, again, over hundreds of thousands or millions of years, this would happen. You have volcanism there. And it wouldn't be a tiny volcano, it would be a fucking huge volcano, because all this material going somewhere. You might actually have a series of volcanoes because of all the piling up, because all this melting material is going to move up, it's going to hit the continental crust, it's going to spread out. So you will have one large volcano event, and depending on the fractalization of the mantle material, as in the different melting processes that will happen there, you could have massive flood basalts all over this place here. The thing is, it would be very different than it is today. That's if we assume something like this could have happened. But like I said previously, there's no reason why a continent will just speed up like that. There's too much friction involved, and there's no cavity in the mantle that causes it to speed up like that. Honestly, don't know what else would happen. I mean, I guess if you really want to study this stuff, you could probably sit and work on this for months on end. But at the end of the day, you're speculating what could have happened if this event here happened. But you're wasting your time, because we know it's impossible for that to happen. So you'd be wasting your energy trying, even if you do show them this, they'll never believe you, of course. Well, this video took way too long to make, and it's been a pain in the ass because of his nonsense. That I was a tiny bit sick well, whatever. It just took too long to make, and I'm fucking happy it's over, to be honest. Anyways, thank you so much for watching. I hope you learned a bit of geophysics in this. Obviously, the real science behind it is more complex. A lot of chemistry actually is involved as well. I refrain from putting chemistry in this video or anything like that, simply because it wouldn't really promote my point. It wouldn't really add extra, because the general idea here is way far up. It's far enough. It's complex enough, okay? So that's it. If you really enjoyed this, do the liking thing down below, and if you want to subscribe, please do the subscribing thing. That's always nice. For the guys who have been subscribed and like my videos and really enjoy my content, I have a Patreon as well. You can do the money thing. Recently Patreon fucked up some little stuff, but they seem to fix it, so that's great. So stay tuned to the Patreon thing. I've got a couple of new patrons. Your names will be put up extra, and some of you will have special rewards, which is coming in future videos. Anyways, thank you again for watching, and enjoy the rest of your day.